Scene script. Have you ever wondered why when you drop an object, it always falls straight to the ground? That's gravity at work. Gravity? It's a word we've all heard, but what does it truly mean? Simply put, gravity is a force of attraction that exists between any two masses, any two bodies, any two particles. It's like an invisible hand that holds us firmly on the ground and keeps our planet in its place within the cosmos. To illustrate this, let's use a familiar analogy. Imagine you have a powerful magnet and a handful of metal shavings. What happens when you bring the magnet close to the shavings? They are immediately attracted to the magnet, right? They move towards it, clinging to it, as if pulled by some invisible force. That's a bit like how gravity works, but instead of a magnet, we have our planet Earth, and instead of metal shavings, we have, well, everything. Every object, every creature, every drop of water, every speck of dust, all are subtly yet inexorably drawn towards the Earth's center. But why does this happen? Why does gravity pull things down? This is due to the Earth's mass. You see, the larger an object's mass, the greater its gravitational pull. That's why the Earth, with its vast mass, pulls smaller objects like apples, cars, and yes, even us, towards it. Yet gravity isn't just a downward force. It's a universal force that acts in all directions. That's why our Earth doesn't just pull objects towards it, but is also pulled by other celestial bodies. It's this intricate dance of gravitational forces that keeps our Earth in orbit around the Sun and the Moon in orbit around us. So, when we talk about gravity, we're not just talking about why things fall to the ground. We're talking about a fundamental force that shapes the universe and everything in it. So, gravity is like an invisible magnet that pulls everything towards the center of the Earth. Now you might be thinking, does gravity only exist on Earth? Absolutely not. Let's take a moment to expand our horizons beyond our blue planet. Gravity, my friends, is not just an earthly phenomenon, it's an universal force, as omnipresent as the space itself. It is the invisible hand that guides the cosmic dance, keeping celestial bodies in harmony. Consider our own solar system. Ever wondered why the planets don't just wander off into the vastness of space? Why does Earth faithfully circle the Sun year after year? The answer is gravity. The Sun, massive and mighty, exerts a gravitational pull on all the planets, including Earth. This gravitational tug keeps the planets in their orbits, much like an invisible leash. Now, let's imagine gravity using an analogy that's a little closer to home. Picture a small marble spinning around the inside of a bowl. The marble doesn't fly out of the bowl, right? It continues to roll along the inner surface, held in its path by the bowl's contour. This is quite similar to how gravity works. The Sun, symbolized by the base of the bowl, pulls the marble or the planet towards it. But the planet's forward motion, or its momentum, keeps it moving along a curved path, rather than falling straight into the Sun. Gravity is like the bowl's contour, providing a sort of cosmic groove that the planets follow. And just as the marble's speed and the bowl's shape can affect the marble's path, factors like a planet's mass and velocity and the Sun's mass influence the shape of the planet's orbit. So gravity, you see, is far more than just the force that keeps us grounded on Earth. It's a universal phenomenon that orchestrates the movements of planets, stars, galaxies, and even light itself. Just like a marble in a bowl, planets stay in their orbits due to the pull of gravity. So, if gravity is everywhere, does it mean that your weight is the same everywhere? The answer might surprise you. You see, weight isn't just about how many burgers you've eaten or how much you've been hitting the gym. Weight is actually the force exerted by gravity on your body. And since the strength of gravity varies across different planets, your weight would also vary. Yes, you heard right. You might be a heavyweight on Earth, but on the Moon, you'd weigh only about 1/6 of your Earth weight. That's less than the weight of your pet cat. Sounds bizarre? Let's dive a little deeper. Imagine you're underwater in a pool. You've probably noticed that you feel a lot lighter, almost as if you could float away. This isn't because you've suddenly lost weight, but because the water is exerting an upward force or buoyancy that counteracts the downward pull of gravity. Now let's take this analogy and apply it to the universe. Think of the universe as a giant pool, and each planet as a different depth in this pool. The deeper you go, the more pressure there is and the heavier you feel. Likewise, the stronger a planet's gravity, the heavier you would feel. On Mars, for instance, you'd weigh about 3/8 of your Earth weight. That's lighter than on Earth, but still heavier than on the Moon. So if you've ever dreamed of being a featherweight, Mars might be the place for you. But what about the giant gas planet Jupiter? With its strong gravity, you'd weigh more than twice your Earth weight. It's safe to say that Jupiter probably isn't the best vacation spot if you're conscious about your weight. So you see, your weight isn't a constant. It's a variable that changes depending on where you are in the universe. The next time someone asks about your weight, you could always say, well, on which planet? And now you'd actually know what you're talking about. Remember, your weight is not a constant. It changes depending on where you are in the universe. Is it possible to defy gravity? To float in the air like a balloon? A question that has fascinated humans for centuries, and one that seems to have an answer when we see helium-filled balloons soaring into the sky or astronauts floating in space. It appears as though they are defying gravity, doesn't it? But let's delve a bit deeper. The helium balloon, for instance, it's not so much defying gravity as it is taking advantage of another force, buoyancy. Let's take an analogy. Imagine a boat floating on water. The boat is denser than the air, but it's less dense than water. This difference in density allows the boat to float. The same principle applies to the helium balloon. Helium is a lighter than air gas. When a balloon is filled with helium, it becomes less dense than the surrounding air. As a result, the denser air pushes the balloon upwards, creating the illusion of defying gravity. Now let's talk about astronauts in space. They appear to be floating, weightless, don't they? But here's the thing. Gravity is still at work, even in space. The astronauts are actually in a state of continuous free fall towards the Earth. But because the Earth is also moving, they never hit it. They just keep falling around it. This is what we call orbiting. In both scenarios, gravity is still very much present. What's happening is that other forces are coming into play, counteracting the pull of gravity. A helium balloon rises because of buoyancy. Astronauts float in space because they're in a continuous state of free fall. So, to answer the question, can we defy gravity? The answer is sort of a yes and a no. We can't eliminate gravity. It's a fundamental force of the universe. But with the right conditions and understanding, we can use other forces to counteract it. And in those moments, it might feel like we're defying gravity, even if we're not. So while we can't eliminate gravity, we can sometimes use other forces to counteract it. So, how does gravity affect our everyday lives? You might ask. Well, gravity, this invisible force, has a bigger impact on our lives than we often realize. It's the quiet puppeteer pulling the strings behind the scenes, shaping our world and the universe in ways we often overlook. Gravity is like a cosmic glue holding everything together. It's what keeps our feet firmly planted on the ground so we don't float off into space. It's what keeps our planet orbiting around the sun and the moon around the Earth. But let's break it down further. Imagine a thick, cozy blanket covering the Earth. That's our atmosphere. It's the air we breathe, the wind that rustles leaves, and the clouds that bring rain. Now, if you've ever tried to hold down a blanket on a windy day, you'll know it's not easy. But gravity does this effortlessly. It's the force that holds down this blanket of air, keeping it from drifting off into space. Without gravity, we wouldn't have an atmosphere. And without an atmosphere, life as we know it would not exist. But gravity's influence extends beyond that. Have you ever stood by the ocean and watched the tides roll in and out? That's gravity at work too. The gravitational pull of the moon causes the ocean's waters to bulge out in the direction of the moon. This bulge is what we see as high tide. As the Earth rotates, the bulge moves around the planet, causing the rise and fall of the sea level. And it doesn't stop there. Gravity also shapes the world on a much larger scale. It's the force that causes planets to form, stars to ignite, and galaxies to spin. It's the driving force behind the birth, life, and death of the universe. In essence, gravity is the silent orchestrator of life. It's the unsung hero, the invisible hand that shapes our world and the universe beyond. So, the next time you drop something and it falls to the ground, remember, that's not just an accident. That's gravity at work. Gravity, the invisible force, shapes our world and the universe in ways we often overlook.